Okay, quiet. Okay. So this just, remember how we did this one. If you have it in slope-intercept form, step 1 is plot the y-intercept. Step 2 is use the slope to find another point on the line, connect the 2 points. So, you try it. Graph that. Okay, what is the m? M equals, oh man, -2, right? B equals 5. Now, the B I put on here, 5. The M, I need the M to tell me how to go up and down and left and right. So if there's no denominator, what do? I make it over 1, -2 over +1, right? So that's telling me how to go from the y-intercept to another point. I don't go from the origin, right? I go from that y-intercept right there. This thing's going to start messing up on me. So that'll go down to right 1. There's my line. I was trying to keep this thing so it didn't start messing up on me. Cancel. Darn it. So parallel lines. What does it mean for lines to be parallel? Yeah, they never touch, but just think about it. If you graph 2 lines, and they're very careful in the book to always say, in the plane, and that's something you may not understand because you didn't go to geometry yet, but what does it mean to say in the plane? What's that? Well, it means on a flat surface, right? Because I could have 2 lines that don't intersect, and they're not parallel. What if I had like one line going this way and one line going that way? Are they parallel? But do they intersect? No. Because I don't really have an idea whether you guys actually have done some of this stuff. That's called skew lines. Skew means they're not parallel, but they don't intersect because they're not on the same flat surface. You know, when it says in the plane, it means it's on a flat surface. Therefore, if they don't touch, they're parallel. It's not like they're like going in like that, right? Different dimensions. So what does it mean? If they're never going to intersect, then it means that they must be going up and over exactly the same. Okay, well, what is the thing that measures how we go up and over? It's slope, right? So when you have parallel lines, they have to have the same slope, right? They got to be going up and over so that they never actually touch. So parallel lines have the same slope. Now, they have to have different y-intercepts, right? What if they had the same y-intercept and the same slope? What's that? They would be the same line. If they have the same slope and the same y-intercept, they are the same line. They're not parallel anymore. Actually, they share every point on the line, right? Not parallel. Okay. I guess that's what it's doing. So let me see if I can do this. So this is their example of giving you a few lines and saying, determine whether they're parallel or not. Now remember, what's the thing you're going to check to see if they're parallel? The slope. If they're parallel, they have the same slope, right? So you calculate, they gave you 3 lines, and all 3 of the lines, there was 2 points highlighted, so you can use it in the slope formula. They might look like they're close to parallel, but until you calculate the slope, then you can't really be sure. Right? So this is them calculating the slope on line A, this is line B, and this is line C right there. So comparing the slopes, which 2 are the parallel lines? A and C, right? This one is parallel to this. And it should be apparent just looking at, yeah. it should be apparent, that just look at how they're going up and over, right? When you don't have points that are highlighted like that, what you should be looking for is where does the line cross an intersection of grid lines? Like it doesn't here, but it does there. Like, so I could go from here. It looks like it's going up 1 over 3, up 1 over 3. Okay, so let me do the same thing here. Up 1 over 3, up 1 over 3. So yeah, they're parallel. This one here, well, let's see. There's an intersection of grid lines, and the next one is all the way up there. So up 2 over 5 doesn't work. What were you going to say? What were you going to say? Okay. All right, let me see if I can make this thing work for 5 more minutes. Determine which of these lines are parallel. So you're going to do the same thing on a U-try, but now you don't have the graph. You just have the points. So calculate the slope 3 times, right? You're going to calculate the slope between these two, calculate them between these two, and then between these two. And see if you get the same slope for any one of those, any 2 of those. So I didn't finish, but I'm trying to do what I can. This pen is starting, when I'm not even touching the screen, it starts writing on the screen, so it gets in, smears a lot. But it looks like the first one is going to be 2/4, which is 1/2. How many got 1/2 for the first line? Okay, the next one looks like it's 4 over 2, so it's 2. And the last one looks like it's 4 over 8, which is 1/2. Did you get that? So let me see if I can, if it's going to let me write just that much, right? So this is 1/2. This is 2. This is 1/2. So which are the parallel lines? Parallel, right? Okay. Now perpendicular, if you had this before, maybe you don't remember, because I could tell you that even in like Algebra 2, when I know kids have just gone through geometry, sometimes they don't remember what perpendicular means. Right? Perpendicular means the lines cross at a 90-degree angle. Right angles, right? Otherwise known as right angles. You know that term already? Right angles? Okay. So if 2 lines are perpendicular, then there's different ways to say this. Most of the time a book would say, well, then if you multiply their slopes, you get -1. The product of the slopes is -1 if they're perpendicular. What that means is it must be that the slopes are negative reciprocals. It means opposite signs flip the fraction. So like if one line had a slope of 4, that means the other line must have a slope of -1/4, right? Opposite sign plus the minus, and then flip the fraction. Since there was no 1 here, then you've got to make it 4 over 1 becomes 1 over 4, right? -3 over 4, opposite sign plus flip the fraction 4/3, right? 1/5, opposite sign, the flip of 1/5 is 5. And every one of those, if you look at it, it should look like the product is -1, right? 4 times -1/4. The 4's cancel, and you're left with -1. -3/4 times 4/3. The 3's cancel, the 4's cancel, -1. 1/5 times 5. 5's cancel, -1. So what you're looking for now to see whether 2 lines are perpendicular is opposite sign, flipped fraction. Now, why do they say non-vertical lines? Why do they throw that in there? Because what's the slope of a vertical line? Try again. It's undefined, right? You can't multiply with a slope which is undefined. right? I mean, it is true. Perpendicular, or horizontal and vertical lines, they're perpendicular, right? They meet at a 90-degree angle. But you can't do this test on that to show it, right? Because you can't use an undefined slope. Let's see if this is going to work for me. Please work. Okay, so determine which of these lines are perpendicular or parallel, in fact. So this is the one I'm doing, if I can. So what do we, before we can start comparing slopes, what do we need to do with these lines? Right? They got to be in slope-intercept form so that you can tell the slope. And if the first one is, but these two are not. So before I start comparing slopes, I need to put it in slope-intercept form. Solve for y. Right? This first one is going to get x plus 5y equals 2. I'm going to subtract x. 5y equals negative x plus 2. Divide by 5. Y equals negative 1/5 x plus 2/5. Okay, the next one, I'm going to add 2x. So I've got negative 10y equals 2x. Divide by negative 10. What's 2 over negative 10? Put in a calculator. What's 2 over negative 10? Make it a fraction. Math, enter, enter. Negative 1/5, right? So this is actually y equals negative 1/5 x. So now that they're all in slope-intercept form, you can make the comparison, right? This one had a slope of 5. These two had slopes of negative 1/5. So which two are parallel? B and C are parallel because they have the same slope. Are any of these pairs of lines perpendicular? What would you look for to tell whether they're perpendicular? Opposite sign, flip the fraction. Okay, what's the opposite of negative 1/5? Positive 1/5. Flip, you get 5. 5 and negative 1/5 are opposite sign, flip fractions. So you could say either A and B are perpendicular or A and C are perpendicular, right? Because these both have negative 1/5. So I'm going to say it like this. Parallel, I'm just drawing the lines like that, is A, B, and C. Perpendicular, usually use a symbol like that to mean perpendicular. It's A and B, or A and C. So see if you could figure out which ones of these are parallel or which ones are perpendicular. Oh, for the first line? Right. The first one had a slope of negative 1/3. The second one is 3, right? Because that's already in slope-intercept form. And maybe the last one is a little more difficult, right? So subtract 4.5x, right? Divide by negative 1.5. So what's negative 4.5 divided by negative 1.5? It's 3, right? So the slopes are negative 1/3, 3, and 3. So which two lines are parallel? These are the parallel because they're the same, B and C. And which pairs are perpendicular? Yeah, both you could say A and B or A and C. Do you have a question? Okay. So these are the parallel, right? And these two are perpendicular. do that. Give it a sec. We're almost done. And it's not going to go. That's okay. So we do this. One note. The homework, because I think that was about all we needed. And let me do here. Page 247. Ah, look at that. Numbers 3 through 8, 14 and 15, 24, 27. In fact, let me do this. There it is. There it is.